Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, minimum operations to form subsequence with target sum. The problem is very interesting, and if you solve it step by step, it's a bit easy as well. So we'll, as always, we'll start from scratch. We'll look at how intuitively we will be able to dissect problem and finally solve the problem. So with that, let's get started. The problem states that you are given a zero indexed array nums consisting of non-negative power of 2 and a integer target. In one operation, you can do the following changes. You can choose any element in the array which is greater than 1 and remove that element from the array and add nums of I by 2 times in the array at the end of the array. You have to return the minimum number of operations you need to perform such that nums contain a subsequence whose sum is equals to the target. If it is not possible at all, you have to return -1. So let's take an example. Let's say nums is 1, 2 and 8. Now you can see this 1, 2 and 8 doesn't contain any subsequence that can be sum up to target. Why? Because you can see if you take 8 in any subsequence, the sum would definitely be greater than 8. So you will not take 8 in any subsequence, and without 8 you just have 3. So you can't make 7 from 3. So there is no subsequence at all which can be sum up to target from 1, 2 and 8. So in one operation, let's say you convert this 8 to 4 and 4. So you just remove 8 and add 2 4s at the end of the array. Now you can see this contains a subsequence that can be sum up to 4, and hence the answer is 1, because in just one operation you are able to convert the given array to something that contains a subsequence that can be sum up to 7. Let's take one last example. Let's say the array is 132, 1, 2 and target is 12. Again, this doesn't contain any subsequence that can be sum up to 12. Why? Because 32, if you take 32 in the subsequence, the subsequence sum would be greater than 32. If you don't take 32, the best you have is 1 plus 1 plus 2, which is 4. So you have to convert the 32 to something lower to make sure that you have a subsequence that can be sum up to 12. So let's say you convert 32 to 16 and 16. So you remove 32, you add 2 16s at the end of the array. Now even this doesn't contain any subsequence that can be sum up to 12 because of the same reason. The best, if you take 16, the sum would be greater than equals to 16, and if you don't take, you just have 4. Now you just remove the 16, let's say, and add back 2 8s in the array. So this is the new array now, and now you can see it contains a subsequence that can be sum up to 12. Why? You can see 1 plus 1 plus 2 plus 8 is actually 12. So in two operation, you are able to convert the given array into something that contain a subsequence which can be sum up to the given target, and hence the answer here is 2. So hope the problem statement is clear. Now how to solve this? So there are two parts in the problem. First, let's say it is given that you have to add the occurrences back to the end of the array. So does end really matters here? I would encourage you to pause and think. So end doesn't matter here. Why? Because finally you need to answer whether the nums contain a subsequence whose elements sum to target, because you worry about subsequences. The position of the element doesn't matter at all, right? So you can safely ignore this to the end of the num from the problem statement, because it doesn't matter if you add nums of I by 2 to some other position. It's just that you will just include that position while considering the subsequence. That's it. So you can simply ignore the order of the elements in the array. That's the gist. Now second page is subsequence. Let's forget about the operations for now. Figuring out whether the given array contains a subsequence that can be sum up to 7 or not in itself is a dynamic programming problem. So basically you are given an array, you have to figure out whether there are some subsequence that can be sum up to the given target. So you can try this out yourself. It in itself is a good problem to solve, but apart from this we have to apply operations, and that too we can apply operation on any nums of I which is greater than 1, and we have to make sure that after applying operations the subsequence sums up to target, right? So sounds a bit complex, right? But let's just try to first solve the subsequence part. Let's say this is the given array, right? And target is 15, so we need to make sure that given array contain a subsequence that can be sum up to 15. You can think of dynamic programming solution and try to code that, but as mentioned, using dynamic programming solution here might not be a good idea because there are other complexity as well which we need to take care of. So we need something better. Now in this problem particularly, we are given that every number that we have given is a power of 2. So from that, what we can try is we can try converting the given target into its binary form as well. So let's say if we are given 15, so we can just simply convert 15 into 8 plus 4 plus 2 plus 1. So this is 15, right? Now we will just see if the given array contains a 8 or not. The given array contains 8, so that's good. Given array contains 4, yes, it contains 4. Does it contain 2? The answer is yes. And finally, does it contain 1 as well, which is yes as well. So because it contains 8, 4, 2 and 1, you can simply say the given array contains this subsequence, or contains a subsequence that can be sum up to 15, right? And notice why it's possible, because the given array is only powers of 2, nothing else, right? So to simplify this even further, what you can simply say, I will convert this array into powers of 2 as well. So I will just say, okay, 1 occurs 3 times in the array, so I will put 3 as a frequency of 2 power 0. Similarly, 2 occurs 2 times in the array, I will put 2 as a frequency of 2 power 1. And similarly, 4 occurs 2 times, so I will put 2 as frequency of 2 power 2, and so on and so forth. Now you can simply compare these two arrays and say yes or no based on the fact that if everything that is set here is present here as well or not. If it is, then the answer is yes, otherwise you can say answer is no. But and you can try out applying the operations in that case and see if answer exists or not, right? So for now, this is simple scenario wherein every element here is actually present in the array, right? But let's take a bit complex scenario as well. Let's assume that the target now is 39. So from now onwards we will deal with this array itself, because this array is actually equivalent to this array. So we'll just deal with this array and we will see if we can convert, or we convert the target into something, or we can convert the given array into something such that every target bit is set in the given array or not. So that's what our goal is, right? So let's say target is 39. So 39's binary format is this: 2 power 5 plus 4 plus 2 plus 1. Now this was the given array. Let's assume that this is 1 as well, like this 1 8 as well. Just assume that. Now think about it. You have 1 1, so that that's fine. You have 1 2 as well, that's fine. You have 1 4 as well, right? But you don't have 1 to power 5, or you don't have 32 in the given array. So you have two choices. Either you can convert, you can apply an operation and bring 32 from a larger number, or you will say, okay, let me not apply the operation, let me see what all is left and can they be sum up to 32. Which one of these two options you will choose? Obviously the second one, because the first operation or the first option will require you to perform some operation, so that incurs a cost of 1, at least a cost of 1. So you will try to avoid incurring any cost until you can. So what you will say, okay, I will try with the remaining elements and see if they are capable of making me 32 or not. So what you will do, you will simply say, okay, I want 1 2 power 0, so there are 2 2 power 0 is left. I want 2 power 1 2 power 1, so there is 1 2 power 1 which is left. Similarly, I want 1 2 power 2, so there is 1 2 power 2 which is left as well. Now if you sum them all up, so you will have 2 2's, right? Sorry, 2 2 power 0, so 2 into 1 which is 2, 1 2 power 1, so you have 2, you have 1 2 power 2, so you have 1 times 4, so you have 4, you have 1 2 power 3 which is 8, and you have 1 2 power 4 which is 16, and if you sum them all up they come exactly 32, right? So basically from the remaining elements it is possible to make the sum 32. So what you can say, okay, I will just make 32 from the remaining elements itself, and I will not perform any operation. In other words, you will say I found these 3 elements because I already subtracted them and from the given array, and from the remaining elements as well I was able to found 2 power 5 as well, and because I found everything that I need, that the given array contains subsequence that can be summed to form 39, you can say that, right? So just to make this a bit more complex, let's say target is 47 and this was the array, right? Now in this case again you can see there is 1 2 power 3, 1 2 power 2, 1 2 power 1, 1 2 power 0, so these 4 are satisfied. Now there is no 2 power 5 as well, so you have to make this satisfy as well. Now again the same trick, you will say, okay, there are 2 ways, either I can make some operation and convert larger element to smaller elements, or I will just see whatever I have remaining with, can I convert it to power 5 as well or not. Now like previously we have 2 2 power 0 remaining, we have 1 2 power 1 remaining, we have 1 2 power 2 remaining, we have 0 2 power 3 remaining, and 0 2 power 4 and others as well. So if you see, we have 2 plus 2 power 2 one times which is 2, 2 power 2 one time which is 4, so we have just 8 remaining from smaller elements. So you can't sum up 8 to make 32, right? So it is not possible to make 32 from the remaining elements. Now because you can't make elements, now is the time you will apply operations, right? So what exactly you will apply here? You can convert this 2 power 6 into 2 power 5, or 2 power 6 is 64, right? So you can convert this 64 into 232. So that is one choice you have, right? Second choice that you have is you can convert this 2 power 7 into something. So 2 power 7 is 128, right? So as per the problem statement, you can convert this 128 into 2 smaller elements, which is 64 and 64. So which one of these 2 operations you will choose? So let's see the power of an operation first. Let's say you convert 2 power 6. So if you convert 2 power 6, you will be converting this 1 2 power 6 into 2 power 5, because 32 is 2 power 5. So you will convert this 1 2 power 6 into 2 power 5. Now you can, in one operation, so this is after t equals to 1, right? Now similarly, after doing one more operation, you will be able to convert this 2 power 5, 1 2 power 5 into 2 power 4. So you 1 2 power 5 will remain, and one of the 2 power 5 will be converted into 2 power 4, right? If you do one more operation, you can convert this 1 2 power 4 to 2, it should be 2, so 2 power 3 as well, and so on and so forth. So basically, finally, if you keep on doing this, just 1 2 power 6 is capable of making everything as 1, right? So if you convert this 2 power 6 into, if you start converting this 2 power 6 into smaller elements, this 2 power 6 is enough to make everything else as 1. right? So because this 2 power 6 is enough, you will not convert 2 power 7 and instead convert 2 power 6 itself. Why? Because if you convert 2 power 7, you need one operation to convert it to 2 power 6 itself, right? So why you will waste this operation? Because whatever this 2 power 7 can do, 2 power 6 itself is capable of doing that as well. So basically it can set everything before itself, right? So because that's the case, you will always convert the one which is closest to you, because that's what will give you the minimum number of operations. So you will convert this 1 to power 6 into 2 2 power 5, so this will become 0 and this will become 2, and now you can see you have 1 2 power 5 that you wanted, and basically you have everything that you wanted. So in just one operation you are able to convert the given array into something that contains a subsequence which sums up to 47, right? So what is the idea to reiterate? We will see what all are matching. If the things are matching, or if the given array has the element which we want, we will simply move forward and remove its sequence. If it doesn't have the element, I will try to make the element from the remaining elements, right? If remaining element sums is equals to 32, I will just take that and not do anything and move forward. If that's not the case, I will find out the first non-zero element on the right and start converting it until I get 1 here. So I will not convert this 2 power 6 to this itself. Instead I will just stop in one step here, because what I wanted is 2 power 5 itself, right? So hope this point makes sense. Let's just take one last example to clarify a few other use cases as well. So let's say the target is 111, so you have to form something like this, right? Now you might be thinking that okay, just like previously we will convert this to 1 1 and 2, right? Now we want to form 2 power 5. Some of you might be thinking that okay, should we, because there is 2 power 6 as well, should we convert this 2 power 6 to 2 power 5, or should we say that okay, I will convert this 2 power 7 to 2 power 5 because this 2 power 6 is already busy? So the answer is it doesn't matter at all. You can do either, and for simplicity you should always try to do the one which is in the right and which is in the left and is nearest to you. So basically in this case as well, I will convert this 2 power 6 into 2 power 5 instead of converting this 2 power 7 to 2 power 5. Now why? I would encourage you to pause and try to think for a moment. So hope you thought about it. If you see, this 2 power 6 was capable of making everything here as 1, right? So with this 2 power 6 you will be able to fulfill your requirement of the right side. Now if you convert, if you have converted this 2 power 6, this will now become 0, so you now have to convert this 2 power 7 into 2 power 6, right? But let's say you do opposite. In opposite, what you will do is you will not convert 2 power 6 at all. You will keep 2 power 6 as it is, and you convert 2 power 7 into 2 power 5. So you require 2 operation here, right? So this operation is exactly equals to what you had previously. You convert 2 power 6 into 2 power 5, and then you convert 2 power 7 into 2 power 6. So here also you require 2 operation. So that's where it doesn't matter which one you pick. You can pick all. You can, for simplicity of the implementation, you can always pick the nearest one which is to the left. So but you can pick either, it doesn't matter at all, though both will yield the same results. So hope this point also makes sense. So the overall algorithm now is, you will just see, you start matching the elements, and if something doesn't match at all, or in other words, if it is set in the target but it is not set in the given array, you have to make that element. So what you will do, you will see if the remaining element is capable of summing up to this or not. If they are, then all good. If they are not, then I will try breaking up from the larger elements. And which one I will break? I will break the one which is small, which is nearest to me in the left, right? So one small thing before you close, some of you might still be thinking that, okay, why, let's say there are elements which can sum up to uh, 40. Let's say, let's erase all of this, right? So yes, so let's say there are elements which can sum up to 32, right? Now, is it possible, or is it always possible to get a subsequence that can be sum up to 32? In other words, let's say there is a element 1 and 3, right? So 1 plus 3 is 4. So but you can't make a subsequence that can sum up to 2, even though 2 is smaller than 4, right? But now here what we are saying is, if we have sum of 32, I will be able to make 32 as well. So how is it possible here, or how we are actually sure about this? The answer is very simple, because everything is a power of 2, and with powers of 2 there is a nice property, is 2 power x is actually greater than summation of 2 power I, where I lies between 0 and x minus 1. So basically, if you sum them all up with 1 1 1 1 1, then also it will be smaller than the next element. Because of this property itself, you are sure that if there are enough elements, or if there are enough sum to make 32, you will be able to select a subset that can make you 32, right? So I would encourage you to think about this for a moment, and and I'm very sure you will be able to get this. So the idea is exactly similar to why we converted the given target to a binary as well, because we have binary numbers. We are sure that we will able to convert this binary numbers to a given number if required, right? So hope the entire solution makes sense. I am not showing the pseudocode, because pseudocode will be straightforward. You will just keep on matching. As and when it unmatch, you will just try to see if the remaining sum is greater than that as well. If it is, you will continue. If not, you will pick the latest one from the left and apply this operation, series of operation, until you get one where you want. So if you want one here, you will apply 2 operations. If you want one here, you will apply 3 operations, and so on and so forth. So basically, you will keep on applying the operation until you get one where you want, and once you get there, you will stop and move forward. So here we want at position 5, so we just apply one operation, and after applying one operation, we move forward with 2 power 6, right? So let's look at the code. The code is exactly similar. We figure out this count array first. So this count array is nothing but this array, where we have the powers of 2. Now after that, we created 2 things, carry and results. And as mentioned, we will, if the bit is not set in the target, then we will simply add it to the carry and continue, right? If the bit is set, it means we need, if the bit is set, it means we need one here, at least one here. So we'll check if the count is already greater than 0. If it is greater than 0, I will simply subtract the count, and remaining thing will be moved to the carry. If it is not greater than 0, it means it is 0 itself. You want 1, but let's say it is 0 itself. So what we have said, we will just say if carry is sufficient to satisfy this need. If it is, I will subtract that. Otherwise, if carry is also not sufficient, I will just move to the left and find the first one which is not set. So which is set. So I will move on to the right, to the left. So I plus 1 31 up to 31, and I will simply find the one which is not 0. And once we find the one, we will continue applying the operation until we hit I, because we want 1 to be present at the ith position. So until we hit I, we will keep on applying the operation. What is the operation? Operation is remove one element here, add 2 elements to the next, and increment the number of operations. So we'll keep on applying the operation until we get non-zero value at I. Once we get non-zero value at I, we will simply do I minus minus and continue. Basically, either you can, once you get 2 here, you have 2 choices. Either you convert this to either you convert this to 1 by saying that okay, I will take 1 to power 5 and remaining will be 1, and I will add this to power 5 to the remainder as well, or carry as well, right? So this is one choice. Or you can simply say okay, I have converted this array to 112. Now let me apply, or let me just move forward and apply the same set of operations to see which one is matching. So basically, if there is already a non-zero element here, this position will itself match, and it will do exactly the same thing. Basically, it will subtract 1 and add back to the carry. So either you can copy these operations here, or keep, or just do I minus minus and say okay, I will, the next iteration will take care of it by itself. So that's just a optimization in terms of implementation, but overall it's doing the exactly same thing. What is the time complexity? Time complexity is simply number of bits into number of bits, which is number of bits square, which in this case is very small, 31 itself. So this, you can see this problem can be solved very easily when it is to power 100 or something, like, or 1000, even 1000 as well. So no issues with that. So hope this entire solution makes sense. If you have any doubts in any of the piece, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.